Actinium, I think, is interesting for several reasons. The first reason is that it's given its name to a whole series of elements in the periodic table, the so-called actinides. The bottom row, usually when you see the periodic table printed out, you have this row at the bottom beginning with AC, actinium. It was discovered a surprisingly long time ago. It was first reported, though there's some argument whether it really was the discovery, in 1899, when it was separated from the ores, the metal ores that were used for separating radium and eventually polonium. These are radioactive ores that I think originally came from somewhere in the Czech Republic, but in Middle Europe, and by very careful chemical treatment they removed these elements. But actinium is a very small proportion of these ores. For each ton of uranium you get less than a milligram of actinium, so there's very little. It is also interesting because it was from actinium that the traces of francium were first detected. The French chemist Marguerite Perret separated very pure actinium, which then decayed or fraction decayed into francium. Now, the thing which really makes actinium exciting is that if you have a lump of actinium or small sample, it's a sort of softish grey metal. Its radioactive decay is so rapid that the air around it ionizes and you get a blue glow around it. So it really is like in cartoons, radioactive materials glowing. And there are not many examples of materials that glow like that. So like many elements, the name comes from one of the properties, in this case the glow, and actinos is a Greek word. I think it may be ancient Greek rather than modern Greek, means a beam or light ray, and it is still used, in other words, in chemistry. When we measure the intensity of light, it is called actinometry. So there is a reason, just in the same way that iridium was named after the colours of its salts, osmium by its smell, actinium from its glow. And in a way, you could say it's a warm, welcoming element, even though it's radioactive. The salts of actinium are perhaps a little disappointing because apparently actinium 3+ is colourless. And this contrasts to, say, plutonium 3+, which has the most fantastic purple colour. I still think that plutonium 3+ is the most beautiful solution of any chemical that I've ever seen. You can see it on our video about plutonium. I thought because actinium is rather a rare element and it's quite radioactive, some of the isotopes like actinium-225 has a half-life of only a few hours, 10 hours or so. I thought that they would be completely useless. But in fact, there are attempts to use them for treatment of cancer. You can attach an actinium atom via a suitable coordinating group to a monoclonal antibody. An antibody is one that will target particular types of cells. So the idea is that you get this antibody into the patient, it will fix to the cancer cell, and then when the actinium decays, its radioactivity will be targeted on the cell to which it's fixed, and all being well, it will kill that cell. I think that it's quite interesting that just because this element is so unstable, it might eventually have a use. It is dangerous because it is the basis of atomic bombs. The second atomic bomb, so-called Fat Man, that was dropped on Nagasaki